That's okay, beta. I can make out, right? I mean, since this is your first class, obviously, you are the new child in the class, so obviously, I can remember this. But yeah, Kartik, if I say your name incorrectly, bear with me, okay? I'll take 1 or 2 classes to be comfortable with the names, okay? Yeah. All right. So thanks Ritika, thanks Kartika, and we have Praneeth also in the class. So for Kartika, this is your first class. So just I'll take 1 minute to make you understand how it works. When I'm teaching the things in the class, I'm focusing more on the concepts, and we'll do some problems relating to that concept. And I ask the kids to kind of try doing that in the class, not to create any pressure, but just to assess that whatever concept we are learning, we are able to apply them. Okay. And if you get stuck anywhere, don't feel bad or shy about it. Just let me know. I'll make sure that we are able to address those gaps to effectively learn what we are trying to learn. And
Okay.
and another thing is, my request to every student here is that make sure that you're not busy taking notes, because whatever I'm teaching, you don't have to take notes and all, because everything is getting recorded. Not you guys, but me and the board. Okay, so you will have this for your reference always. You don't really have to worry about kind of being busy taking notes, or being worried about something getting missed out while you're taking notes. Okay, don't worry about it. All right.
Yeah, understood.
Okay, so we have Dhanvin also now, and Gautam as well. So let me do a quick roll call and we'll start. So we have Deep, Dhanvin, Gautam, Kartika, Rehan, Ria, Ritika, Smarni, Sunarka, and Vishal. Some kids are not there, and we have Praneeth in the class as well, apart from me. So some of the kids who are not in the class, they will have to watch the video. So whenever you miss a class, you have to just watch the video of the class and try doing a unit test on the Khan Academy for the related topic. And if you get stuck anywhere, reach out to me, say, okay sir, this one I could not do, I'm struggling. And I'm okay teaching the same concept as many times you guys want me to. My only goal is that every child in the class, you guys are all like silent for me, okay? So every child in the class is comfortable with the concepts, and you are confident when you are dealing with those problems. All right. So in yesterday's class, we were learning about percentage, and again, there is nothing to learn. We were more dealing with some of the sample problems related to percentage, and we solved one problem. What we'll do is in today's class, we'll probably take one more word problem from percentage. We'll try solving it together, and then we'll move on to the next chapter, which is more around center and spread of data. So basically, we'll be talking about mean, median, mode, and standard deviation. And we'll not only talk about how to calculate that, but we'll try understanding why it is relevant and what is the interpretation we can draw from these understanding or concepts. Okay, why in the first place we even need to figure out what is standard deviation? How does it actually help? Yeah. Is everybody okay with that? So let's start with the first part, which is doing few sample problems on percentages, and I know everybody in the class knows about it. We're just dealing with the word problems, or the kind of problems that you guys will deal with when you do your SAT exam. Okay, so let's look at one of the problems. So let's see what is the kind of problem that might become a problem for you guys when you're dealing with them. So again, for Kartika, it will be a new thing. There's a concept that all my kids hate me for, and that I call as RAN. The story behind that is, whoever wins the race or whoever performs good in a race depends on how he or she ran in the race. Now, let me decode RAN for some of you who are not familiar with it. R stands for reading, meaning this is all about the strategy that we follow for solving every problem. Meaning, R stands for reading, meaning when you have a question, read it once, twice, 3 times, 4 times, till you are confident about what exactly the question is saying. So read it till you get tired, or till you feel that okay, there's nothing more that you'll learn by reading it one more time. And then comes analysis. Meaning, once you have read the question enough, then you start putting your thoughts together, say, okay, fine. This is the problem. These are the information I have. These are the concepts that I'm aware of. This is how I'm going to solve the problem. So you're actually making a blueprint in the A phase. And then comes N. N is the short form of Nike. What does Nike say? Just do it. So, in summary, what it means is, when you have a problem to solve, read the question enough, be confident about what you're trying to solve or what you're being asked to solve, then analyze, make your plan, and then you start doing it. Where we go wrong is, you got a question, you start solving it. And that is where you might go in the wrong direction, and if you go in the wrong direction, you end up spending time which might not be effective or fruitful for you in an exam-like scenario. So you have to always do it right, and you have to always do it effectively. So that's what this strategy helps you with. Some of the kids who have heard me saying the same thing 100 times, they might be tired, like Praneeth is holding his head like this, oh man, one more time. But then I'll keep on reiterating this because this will become a practice for you guys. This will become a habit. Then okay, any problem you have to solve, don't jump onto the problem and try solving it. Put your thoughts together, make your plan, and then you try doing it. Alright, and we will see merit in that. So the problem that we are going to solve today for percentage, again I am assuming that everybody knows what is percentage and how to calculate percentage, but the kind of problem that we have to deal with, that is what we are trying to solve here. Okay, the question, I'm going to apply the same concept, read, analyze, and then Nike. The question is, hear me out clearly, okay? I'll say it one more few times. The earth has a mass of approximately 6 I don't know if it's 6 point, no. Yeah, it's okay. The earth has a mass of approximately 6.10 to the power 24. So I'm assuming this is 6 into 10 to the power 24, okay? And why I'm assuming that, I'll come to that. The earth has a mass of approximately 6 into 10 to the power 24 kilograms. The volume of Earth's ocean is approximately 1.34 into 10 to the power 9 cubic kilometer. So cubic kilometer. Okay. And ocean water has a mass of about 1.03 point or into 10 to the power 12 kilogram per kilometer cube. To the nearest 100th of a percent, what percent of Earth's mass is from ocean? Okay, so you heard this question once, and I'm sure everybody is confused. Hello, Dhanushri.
Hi, sir.
So I'm reading the question one more time for you guys, and this is where you will see the merit in what I was saying. When you read a complex looking question like this, it's a wake up call for reading it a couple of times. Let me read one more time. The Earth has a mass of approximately 6.10 to the power 24. So it's actually saying 6 into 10 to the power 24. That's what we'll assume. The Earth has a mass of approximately 6 into 10 to the power 24 kilograms. The volume of the Earth ocean is approximately 1.34 into 10 to the power 9 kilometer cube. And ocean water has a mass of about 1.03 into 10 to the power 12 kilogram per kilometer cube. To the nearest 100th of a percent, find what percent of Earth's mass is from the ocean. So now, after having heard this question 2 times, what we know is we are given the mass of Earth as this, and it says the volume of Earth's ocean is this much. This is the volume. This is the amount of water that we have in the ocean. And this is where it's relating the volume with the mass. It's saying ocean water has a mass of about this much kilogram per kilometer cube. To the nearest 100th, find out what percentage of Earth's mass is from ocean. So this is the question. I would want you guys to look at this question and tell me what will be your approach for solving it. And if you are okay to solve it by yourself, nothing like it. Everybody heard the question, right? Is that a fair assumption?
Can you say it one more time?
Okay. So I have put the numbers on the board, but I'm reading it one more time. The Earth has a mass of approximately 6 into 10 to power 24 kilograms. Straight simple line. The volume of Earth's ocean is approximately 1.34 into 10 to power 9 kilometer cube. The volume of Earth's ocean is 1.34 into 10 to power 9 kilometer cube. The next line says the ocean water has a mass of about 1.03 into 10 power 12 kilogram per kilometer cube. Okay? To the nearest hundredth of a percent, what percent of Earth's mass is from the ocean? So now you can imagine, right? I mean, Earth. If you look at Earth as the blue shiny ball that we are all aware of. I mean, obviously, which has the land, inland also. It has, you see, 2/3 of that is actually water or ocean. So this is the calculation. It says this is the mass of the Earth. This is probably the total mass. That's what I would read from the question. And this is the total volume of the water that the Earth's surface holds. Okay. Now it says that this is the density of the water. It says this many kilograms per kilometer cube. So you have the volume, you have the density, and you have to find out what is the total mass of the ocean and what is that percentage against the total mass of the Earth. Kartika, how was the first question that you came across? Are you able to at least follow the question? Let's not worry about how to solve
I was
it.
able to follow the question. It's just the part where you solve it. I think I got the wrong numbers, but
Yeah.
I know how to solve it. I just don't think I have the right numbers.
Okay. Would you want me to give you the numbers one more time?
No.
Okay. Okay, let's see how. See, this is your first class, so I would not want you to get stressed out. Let's see how everybody is approaching this problem. Okay. And I'll keep on emphasizing on this. So read the question again. That is why Vishal asked the question, just to make sure that he has read the question. And now I believe everybody is doing the analysis. And then they will come to Nike.
I got the numbers that you said.
Uh-huh.
It's just that I want to see how one of these problems are worked out before I try it.
Okay, no worries. Yeah, Pranit, you were saying something.
I know the approach of how to do this.
Okay.
So, since we know how much one kilometer of volume, 1 kilometer of water's volume is, which is 1.3 to the power 10, that's our unit rate. Then we know how much kilometers cubed we already need.
Mm-hmm.
So we'd multiply 1.3 times 10 to the power 12 kilograms per kilometer square times 1.34 times 10 to the power 9, which would give you, the kilometers would cancel out,
Mm-hmm.
leaving you with kilograms, and then that kilograms divided by 6
Mm-hmm.
to 6 times 10 to the power 24 would give you your percentage.
Yeah. So do it to the nearest percentage. I mean, you don't have to be accurate, saying okay 6.92 kind of thing. Give me a ballpark, and that should be enough. So can I assume that everybody except Kartika? I mean, I know Kartika also said that she also knows how to do it, but can I assume that everybody else in the class, Smarni, Ritika, Sunarka, Deep, Dhanushri, everybody is able to give it a shot? Ria? Okay.
Yeah.
Okay. Give it a shot and don't be afraid of being wrong. Being wrong is fun. That's what we are here for. I want you guys to be wrong. That gives me an opportunity to teach something. So don't even worry about, oh, I did something and that is wrong. Everybody will laugh at it. There's only one thing that you guys have to laugh at. That is my poor jokes. Nothing else is a matter of laughter. So I'll give you guys 2 minutes, and then probably I heard one approach from Praneeth, and I would want to hear at least 2 more approach before I give it a shot.
Could you repeat the question once more?
Okay.
I mean, like the question part of the thing.
Right.
Like, what are we supposed to find?
Number to the nearest thousands or tenth?
10th. So Dhanvin, here's the question, okay? It says, Earth has a mass of approximately 6 into 10 to the power 24 kilograms.
Mm-hmm.
The second line says, the volume of Earth's ocean is approximately 1.34 into 10 to the power 9 kilometer cube.
Mm-hmm.
You have the volume of the ocean given to you. Now the next line says, the ocean water has a mass of about 1.03 into 10 to the power 12 kilogram per kilometer cube.
Mm-hmm.
So this is like density given to us.
Yeah.
It says, find the percentage of mass that the ocean water is holding, okay, against the mass of Earth.
Mm-hmm.
So,
Okay.
so this is the total basically. You have, it's like a part to whole scenario, okay. So this is your total, and this is your part, and you have to derive the percentage.
Okay. Yeah.
So the question which was looking so very cryptic when I started reading it, and that too in my strong Indian accent, I'm sure you guys would have thought, where is this old man going? And when I read it a couple of times, now it has come down to becoming a very simple calculation that we're talking about. So that I would just want you guys to do the calculation now and tell me what is that. No worries, Gautam. So I'm just wanting to hear it from 2 more kids. I heard one approach from Praneeth. Anybody else who wants to just give the approach? Even Kartika, if you know that you know the approach, you can just talk through the approach. What would be your approach? Don't give me the numbers. Just tell me the approach. How will you approach it? Or anybody?
Wouldn't you divide maybe the ocean mass by the Earth mass?
Mm-hmm. Right. Once you divide the ocean mass by the Earth mass, that will give you the percentage. But how do we have the ocean mass already?
I thought one of the numbers read aloud was the ocean mass.
So this says the ocean mass. Look at one thing here. So let me try solving this for you guys, okay? I know everybody is trying and we are probably trying the same way. But look at this one. This says mass in kilogram. This is the mass of the Earth. When it comes to ocean, I am given that the total volume of ocean is 1.34 into 10 to the power 9 kilometer cube. This is the volume, right? I mean, if you talk about the volume of anything, right? Let's say we talk about volume of a cuboid. How do you find it? You say, okay, length times width times height. So you have, let's say length is L kilometer, this is width kilometer, and this is height kilometer. So length into width into height, and then you have kilometer into kilometer into kilometer, which makes it kilometer cube. This is pure play volume of the cuboid. Same way, so you are given the volume, the space that the total water on the surface of Earth will take. That is the volume. This one says the mass of the ocean water is 1.03 to 10 to the power 12 kilogram per kilometer cube. So this is not the mass actually. This is the density. It says every kilometer cube of the ocean water is weighing this much. But your total volume, every kilometer cube is this much. But how many kilometer cubes of volume you have? You have this much. So basically, look at this. Now, in the latest form, if I want to do the calculation here, I cannot deal with apples and oranges together. If I have apple, I'll add apple with apples, oranges with oranges. That will be my way of dealing with them, right? I'll not say 2 apples plus 3 oranges equal to 5 apples or 5 oranges, right? There's no negotiation between them. They are different. So likewise here, if you look at this is my mass. Let's say if I have to find out percentage, what percentage is 10 out of 50? So you'll say 10 by 50 into 100 and you calculate that. Here when you're trying to calculate the percentage of ocean's mass, you have to find out ocean's mass against this guy. So your Earth's mass is 6 into 10 power 24 kilograms. Now you have to find out something in kilogram and then you multiply that by 100, which will give you the percentage that you're looking for. Correct? Just 1 second. Just 1 second. Yeah? Don't make me do all the big things. I'm in the middle of a class today. I cannot do it. Okay. Yes. No, don't make me do that, sir. I'm in the middle of a class. I can't do that. It's not even done.
You just use your fingers like this.
Okay. Yeah. Thank you. Thank you. Sorry, kids. There was a small distraction. Okay. So coming back to this one. So I have the mass of the earth. I need mass of the ocean in kilograms. Do we have anything in the kilogram? I have volume given and I have density given. It's kilogram per meter cube, kilometer cube. This is kilometer. So I have to find out the mass of the ocean first. Are you guys with me so far?
Yeah.
Yeah. Tired of me? Okay. Let's do it a simpler way. So first thing first is we have to find out we know the mass of the earth, we have to find out the mass of the ocean. And that will be my way to calculate the percentage. Now, what I have is the total volume, meaning the total volume of the water in the ocean is this much. This is the volume. This is the space that it needs for holding the water that we have on the earth's surface. Now, this one says 1.03 into 10 to power, this is the mass, 10 to power 12 kilogram per kilometer cube. So I have this much of mass per kilometer cube. How many kilometer cubes I have? This many. That means my total mass of the water on the surface of earth is this times this. I can read this. This much is the mass per kilometer cube. What is my total volume? This much. So I have to multiply this guy with this guy to get the total mass of the water on the surface of earth. Is that part making sense to everybody? I will not move on unless I hear a solid and a confirm yes. Yeah?
Yeah.
Smarni,
Yep.
Kartika, Ria, everybody?
Yes.
Okay.
I have understood.
Now you understood? Dhanushri, okay beta? Dhanushri, Rehan, everybody clear, right? Sunarka? Okay.
Yes.
Okay. So now we know that, okay, how I can find out the total mass of the water on the surface of earth. This is per kilometer cube this much, I have this many kilometer cube. It's like 1 pound of potato costs you $3. This many pounds of potato you have to buy. So this is going to be a simple 1.03 into 10 power 12 and multiplied by 1.34 into 10 power 9. And one thing I do on purpose is I don't ignore the units, okay? Because that's more like a wake up call for me always. So I will write the units also here. It's kilogram per kilometer cube. This is coming from this guy and this guy's unit is kilometer cube. Okay? So in a way what I see here is I can do kilometer cube and kilometer cube tic-tac-toe. So see, now I'm left with something into something kilogram. And that is relatable to the mass that we see here. Correct? Everybody? So imagine a situation where I was ignorant of the unit and this was given as gram per kilometer cube. My answer would have gone for a toss. So that's why if I'm not ignoring the unit, my cushion is better actually. Yeah. So make sure that when you're doing calculation, don't ignore the unit because unit could force you in a wrong direction and which will lead to a wrong result. So now here I'm doing some rough calculation. Okay, I'm not wanting to go very accurate with my calculation. So it's 1.03 into 1.34. So it will be somewhere around 1.4. I'm just making it up. Okay. And then multiply that by 10 power 12 and 10 power 9. That makes it exponents, multiplication that 12 plus 9. That becomes 10 power 21. This much kilograms. Okay. Now you're talking about this is your mass of the ocean and this is the mass of the earth. This is the whole, this is your part. So find out the percentage of mass of the ocean against the mass of the earth. So it is going to be 1.4 into 10 to the power 21 divided by 6 into 10 to the power 24. Here you have a kilogram. Here also you have kilogram. Okay, don't ignore that. And put 100. That will be a percentage. So kilogram and kilogram you can do tic-tac-toe. Done. 10 to the power 21 by 10 to the power 24. So it becomes 1.4 by 6 into 10 to the power minus 3 into 100. 100 is nothing but 10 to the power 2. Okay. So this becomes 1.4 by 6 into 10 to the power 2 and 10 to the power minus 3 becomes 10 to the power minus 1, or you can say this as 1.4 by 6 and into 10 to the power 1 or 10. This becomes 1.4 by 60 or 0.7 by 30. This much percentage. Now you can calculate how much it will be. It's like 1/40th actually. It will be almost like 1/40th. Approximately I'm saying. 1/40th would be somewhere around 0.025 or something like that. Yeah, maybe around 3. Does it actually make sense so far to everybody? Mostly? Okay. Okay, because I never claim that I explain things in the best possible way. I might not be the best teacher. So that's why I'm asking you guys to confirm whether I was able to explain that successfully to you guys or not. Yep?
Yeah.
So Gautam, you are saying something and you are typing. I want you to say it loud and clear. It's okay. I've been trying to understand the part before the percentage solving, but it is confusing me. Okay, fine. So, before percentage, meaning once you got the mass of earth and mass of ocean and mass of earth, then you can derive the percentage. That part is clear. Now, the question here is, how did we find the mass of ocean? That's your question, right, Gautam? Yeah?
Yes.
Okay. Now, forget about you being in a class. Look at this like a baby. See that there are 3 informations given to us. Okay. First information is, that's where I was reading the question again and again. So I'm just giving you a summary of what we have in the question. This is the total mass of the earth. Like mass of potato, mass of tomato, or mass of rice, mass of pulses, mass of banana, whatever you buy from the market, right? You always buy in pound. That's a US customary system. When you go buy the same thing in India, you'll buy that in kilogram. So we are given the mass in kilogram. Okay. Now, second information that we have been given is the total volume of the water on the Earth's surface in the ocean is 1.34 into 10 power 9 kilometer cube. How do you interpret this? It says this is total volume, meaning the total space taken by the water. If you have to imagine a container in which you are going to keep all the water on the surface of Earth or in the ocean, the volume of the container has to be this much. Then only you can hold it all. Yeah? Gautam? Yes? Okay?
Yeah.
Now, the other information that we are given is the mass of water in the ocean. Again, see, you can imagine there are some things which look big but weigh less. Right? Think of the pillow that we put our head on while sleeping, right? Think of that pillow versus think of I'm sorry? A dumbbell maybe, or even a laptop. Laptop looks smaller in size but might weigh more than your pillow actually. Yeah? Because, so why it looks bigger? Because it has a bigger volume. It needs more space to keep it. You cannot put a pillow in your pocket because your pocket has less space, less volume to accommodate. Wherein pillow needs more space. So this is nothing but the space or the volume. Here this is giving you the amount of thing that is stuffed. So now coming back to the pillow and laptop example, the amount of things stuffed in the laptop in the small space is much more than the amount of the cotton that you have in the pillow. It's very lightly, loosely coupled. So the amount is less. That means the mass is less. Okay. So this is giving you that relationship. It says this is the total space taken, but this is the weight of ocean water for every kilometer cube. For every kilometer cube. Now, how do you relate that? If you think of a container which is 1 kilometer in length, 1 kilometer in width, and 1 kilometer in height also. Okay, 1 kilometer. If you fill this container with ocean water, it will weigh this many kilograms. Yeah. So every kilometer cube, every container like this will weigh this much. How many such you have? You have this many kilometer cubes. Meaning every kilometer cube, every container which is of dimension 1 kilometer length, width and height is weighing this much kilograms or this many kilograms. Wherein you have this many kilometer cubes, meaning this many boxes like this you have. So what is the total mass you are talking about? You are talking about this multiplied by this. So 1.34 into 10 to the power 9 multiplied by this 1.03 into 10 to the power 12. This gives you the total mass of the water, ocean water that you are dealing with. Does it make sense now, Gautam?
A little more, yeah.
Yeah. So again, see this problem or this kind of problem has no weight in it. Weight as in these problems are not deep as per your way of defining things, right? You guys say, okay, this is not deep. So this is actually not deep. It is just, you have to just visualize that. You have to just interpret that, okay, fine, I am given this and I am given this. What is the relationship here? I see here this is kilometer cube. Here it says this many kilograms per kilometer cube. Per kilometer cube. So every kilometer cube is this much in weight or mass. So I have this many kilometer cubes. So let's say every kilometer cube is, let's say, 10. If I have 5 kilometer cube, I'm talking about 10 into 5 in the mass. I have this many kilometer cube of volume. So I have to multiply with that number. And then that is what will give me the mass. Make sense? Gautam, everybody. It's a question for everybody, okay? This is your last chance. Otherwise, I will move on to the next one and then I'll go with the assumption that everybody understood. Yeah?
Yeah.
Yeah? Alright. So, now the point that we have as a takeaway here is percentage problems are not as scary as we think otherwise. What do I mean by that is, if you look at this question's journey so far, when I started reading it for the first time, I was thinking that, oh, this one is probably, a heavyweight one. When I read it 2-3 times, I found, oh, this is just simply talking about basic, percentage calculation. Yeah, Gautam, leave that emoji. Okay, so then when I read it a couple of times, I saw that, okay, this is talking about simpler question. When I did the analysis, okay, I could relate, okay, this here, it gives me per unit mass and I have this many units. When I multiply them, I get the total mass. And I know how to calculate percentage. So this analysis phase made my life much easier. Then when I went to N or Nike, for me it was simple calculation. Multiply this with this, whatever value you get, that divided by this into 100 is going to be your percentage. So this Nike phase was the most brainless phase, I would say. I'm not saying that Nike doesn't have brain. I mean, Nike, any shoe will not have brain for that matter. But what I'm saying is, by the time you come here, you have no thinking pending to be done. You are already done with what is the information you have, what is going to be the approach. Here you are just doing the manual activity. That's what I was doing when I was solving this problem. Does it actually make sense? Yeah? Ritika, Ria, Smarni, Vishal, everybody? Yeah? Okay. Alright. So I can go on picking problem after problem on percentage and I can keep on bothering you guys, but I would not do that. It's Sunday already and you guys are about to finish your school year. No, that was a joke. Coming back to a serious point, I would want you guys to pick up the unit, percentage unit in Khan Academy. When you go to Khan Academy Digital SAT Prep, go to this unit. Just randomly go to the unit test of percentage chapter, okay? And you'll have probably 4 to 6 problems there. Try solving it. Not to solve it for yourself. Say that, okay, let me see whatever this old man has taught us so far, is that enough for us to be able to solve this problem? Is that RAN approach good enough for me to be able to address these problems? And if you are able to do so, you are done. If you are not able to do so, that gives you an opportunity saying, sir, there was one problem that probably was a little more tricky than what I thought, and I'm not able to solve it. Can you help? Or you will say, okay, whatever you taught, that was probably not the most appropriate way. I have a better way of solving it. That is also fine, because more you deliberate with a problem, more expertise you are building for yourself. And I keep on requesting all the kids here in the group that whenever you find something interesting, something new, don't hesitate to share. Because when you share, you're not caring for others, you're caring for yourself. More you deal with the problem, more you share, more you kind of deliberate those problems, you will see that your expertise, your knowledge level has gone to next notch. Okay? Let me not continue with my gyan further, but yeah, this is just more of a request for you guys. So I'm not going to deal with percentage problem anymore. I will let you guys do some unit test and let me know if there is something that you found more interesting or something more complicated than what I'm saying right now. Okay? And then we'll deal with them. Is that okay?
Yes.
Shall we move on to the next topic? So next topic is as forgetful as I am. Right. Yes. Yes, Gautam, tell me. What do you remember?
Wait, no, never mind. I forgot.
Okay. So next topic is center, spread and shape of distribution. Mandeep, welcome to grade 3. You'll have more fun. You are 17 minutes early for the class, beta, okay? I'm dealing with a lot more interesting, complicated topics which you might not find interesting, okay? So join after 15 minutes, that'll be the right time. Alright, So we are talking about center, spread and shape of distribution. In simple terms, we are going to talk about 4 topics primarily: mean, median, mode, and next interesting stuff would be standard deviation. Okay? And most of these things you guys would be knowing, more or less. But I have $1 million question for myself and you guys as well. That why do we even need to learn about these things? We know how to do calculation, we know how to do addition, subtraction, multiplication, division, percentage calculation, interest calculation, whatnot. We also learn how to do area or differentiate, volume, surface area, whatnot. And then we learned even sine cos 10. What is the extra value this guy is bringing to the table? How does it even make sense, or how does it even stay relevant for us when it comes to learning maths? And the kind of blabbering I'm doing, I want you guys to do similar level of blabbering and tell me what is the underlying force or driver for learning this even. I mean, we are not going to learn anything in the class unless we are convinced what we are learning. So, if I ask this question to Kartika, Dhanven, Riya, Smart, anybody, can you guys tell me why do we even need to learn this?
To find the average product price, or which one's the best depending on who bought what.
Okay.
Using this, we can find hidden trends and stuff like that inside of data. So, like big data, they use this for finding trends out of big data. So, like it's used in almost everyday life. We use this.
Okay. So, Pranit said something, whatever you said, Kartika, that certainly makes sense. It gives you a way to find out, getting some insight into data by finding what is the best data, what is the lowest data, highest data kind of thing. And then Pranit added more to it, saying that it helps you find out some hidden trends within the data. And now you say, okay, what is so hidden about it? As you guys would know, probably this is my 26th year running in the IT industry. When I started my career, I was a pure play developer, writing code in different technologies, Java, .NET, Visual Basic, Power Builder, Oracle, whatnot. My life was going fine for initial 5-10 years with whatever coding I had learned. And then came a sudden change in the way industry works, where in the earlier times people were only saying, okay, I'm an IT professional, I know how to write code. Now IT itself is transforming to a great extent, meaning nobody is caring much about the building tools or applications, because there are a lot of fancy tools. AI gives you everything ready-made, in fact. So the transformation that happened was, okay, every industry, every company, every business, every domain is having a lot of transactions, a lot of users, a lot of data happening, right? I mean, if you take simple example of USPS, they are dealing with entire 350 million people here in the US, and every mail that you send, that becomes the data. Okay, somebody send mail from one person to another person. Some states sending more email, some states sending less email, right? Some age group sending more email, some age group sending less email. People who are in working, they are sending more email versus people who are retired. There's a lot of insight into the data. So everybody has the application or the platform for dealing with the transactions. Now focus shifted from understanding the behavior of data, looking at the data to derive some trend. Now think of a situation. When we go to Walmart to buy something, you see a lot of things stacked in the front of the store versus things being in the back of the store. And you know what? That is based on the trend. If there's a Christmas about to come, they'll put all the Christmas stuff in the front of the store because they know that these are going to move fast. That is where we can make more money. If they know that there's a graduation coming closer, then they put all the stuff related to graduation, the gifts or bouquets, flowers, whatnot, in the front of the store so that that can move faster. They would not want people to go do a treasure hunt to find out where the gift items are, which is going to fly much faster than others, right? So all that is actually hidden in the data. The information, everything around us is actually data. And all these things that we talk about, be it mean, median, mode, standard deviation, these are some of the interesting tools that help you get a better understanding of the data, understand the trend, and then extrapolate that to find what could be there in future. Let's say for last 5 years, we have seen that during the Christmas time, the sales are increasing every year by 20%. So if last year I was keeping, let's say something, a Christmas item 100 in quantity, since I see the trend of 20% increase year on year, I'll keep 120 or maybe 125. So these tools or these insights into data helps you to predict the future and plan accordingly. Okay, so that's a very, what do you call, that's a very deep rooted information that we need to be aware of. It is not just about how to calculate mean. Mean is very mean, right? You guys say you're a mean teacher, you don't tell the right concept. So again, jokes apart, how to find out mean, median, mode. 20 people in your neighborhood can explain you. What you need to look at it is why. As soon as you get the answer for the why, you will find more interest in the subject, and that is where you yourself will be motivated to go deeper into the concept and understand or interpret that in a different way. That's what I'm trying to inject in my classes. Okay. Otherwise, if it's just about teaching you the mean, median, mode, I'll say, okay, mean is like sum of all divided by the number of items you're talking about. Median is calculated this way, mode is calculated this way. I'm not saying that I'll not teach that, I'll still teach that. But I'm just trying to injecting that when you're talking about this thing, there's a reason for it and there's a future to it. Was that a good speech?
Yeah, that was good.
Yeah, okay. You guys don't have to be shy. Sometimes you can appreciate me for my speech, huh? But on a serious note, there's a reason for whatever we learn, okay? You guys learn percentage because when the Thanksgiving comes, you'll be able to compare that, okay, store A versus store B giving me two different deals in two different cryptic ways, but I know how to decode them and find out what is the best deal for me. That's why we learn percentage. When you learn about interest, compound interest, simple interest, you learn how will you survive when you grow up, once you start working for yourself, and then you have to choose between different banks where to put your hard-earned money to make maximum return out of it. So everything that we're learning has a future to it. Okay. All right. Now let's come back to what we want to learn. So I don't think we will be able to cover everything in next 8 minutes that we have. But let's look at what are the things that we know and what are the things that we will continue to learn in the coming class. So mean, everybody knows. I heard one word from Praneeth that is spot on. If I say mean is nothing but average. Yeah. Does everybody in the class have the same understanding or anybody has a different point of view? Yeah. So if when you say mean of a number, you're talking about average. If I have 4 numbers and you have to find out the mean, you say, okay, we have to just find out the average, meaning add them all together and divide that by how many numbers we had? 1, 2, 3, 4, 4. So this gives me 2 plus 6, 10. 2 plus 6, 8 plus 9, 17 plus 11, 28 by 4. You got 7. Now, when you look at this number 7 is actually giving you the right trend. When you look at the average or the mean, it actually tells you that, okay, even if you had a very small number as 2 and a very big number as 10, but there is something in between these numbers. That gives you the central behavior of the data that you have. Yes, Gautam.
In the numbers you put 2, 6, 9, and 10, but
in the equation you put 2, 6, 9, and 11.
That is because I'm getting old. Yeah? Alright. But nevertheless, it doesn't change the overall message that I was trying to convey here. Now, this becomes what? 4, 6 are 24, 3, 4, 6.75. Little less than 7.
It rounds to 7, so.
Yeah. So maybe 6.75. But still, if you look at the message that I'm trying to convey here is, this gives you the trend of the data. These are extremes, but this tells you the center point of the data, right? Let's say if this is the number of candies given to 4 kids. If you have one more kid coming, okay, 5th kid also, we don't know how many. How will you plan? I say, okay, fine. For the 4 kids, I had distributed around 6.75 or 7 candies. If I arrange 7 or 8 candies, this will take care of the 5th kid also. So this helps you predict the future part of it. This helps you plan. This helps you anticipate what kind of preparedness you would need. Yeah. So this is, again, finding out mean I can finish that in 2 minutes. But why I'm emphasizing on this is because this data is not the dumb looking data which has no interesting element to it. It has interesting element to it. Okay? We will see, and you don't be surprised. You will see that when you talk about these numbers, when you guys grow up a little bit more, start getting into pre-calculus, calculus stage, you will see that all these things are actually looked at with a different perspective altogether. Okay? So data is going to be a very, very important part of everybody's life. No matter whether somebody like me who is approaching 50 versus somebody like you guys who is below 15 even. Okay? So data is going to play a very important role in your life. You guys argue, fight with your parents every day, saying, okay, fine. For last 5 days, you were giving me $5 as pocket money, today only 2. Are you fighting? No, you are doing data analysis. Yeah? You are analyzing the data from the previous 5 days and then relating that with the data today, and then you are making a judgment out of it. Yeah? So that is going to remain a very, very crucial and important part of our life. And we'll talk about mean, median, mode, and we'll do some word problems and standard deviation in the coming class also. Alright, which will be on next Saturday. I hope we learned something interesting, and we'll keep on learning interesting. If you don't find something interesting, let me know. I'll figure out ways to make it interesting. Yeah? Alright. With that being said, I'll let you guys go and enjoy the rest of your evening. See you guys next Saturday, same time. Alright. Yep, bye-bye.
Bye.
Bye.